Hello, good morning, good afternoon, and good day from wherever you're joining us. This is day 2 of the free program, Fundamentals of Machine Learning, and it's brought to you by Hamplus Hub, otherwise known as Hamplus Technologies International. And for this training, we'll be using contents gotten from our sponsors. The one we use, the content gotten from Global AI Hub. Day 2, which is today, we are using the contents from Data Scientists Network, which is otherwise known, which was formerly known as Data Science Nigeria. And today, like said yesterday, we'll be creating a model using linear regression, which will be our first model. We'll develop this model and we'll try to understand how machine learning actually works. Before the practical section, we'll go through the file you can see on your screen. We'll go through the file, which will introduce us to linear regression. Linear regression is under the supervised learning. Okay, so in machine learning, we actually have basically three types. In some literature you see it as 3 types, some you see it as 2, some you see as just 4 types of machine learning algorithms. The first is the supervised learning. The second is the unsupervised learning. Then we have semi-supervised learning. Finally, we have reinforcement learning. Now, in the supervised learning, you'll be presented with a labeled data. You use it for your training, of the model. In supervised learning, your data are labeled. I have different labels which you can use for training. In unsupervised learning, you don't have a label. That is, your data does not have a label. I'll simply say, in unsupervised learning, you don't have a target. You don't have those that are advanced in machine learning. You understand when I say you don't have a target. You only have your data, the features, but you don't have your targets. Okay, but in supervised learning, you have both your targets and your features. Okay, just like the literature have it, supervised learning can be divided into regression and classification. Regression and classification are both part of machine learning algorithm called supervised learning. Now, what is regression? When we look at regression deals with a continuous an output that is in a continuous form. That is, what you're working on is continuous. It's like 1.0, 1.5, 1.4, there are values in between. it is not an A or a B. It's not a 1 or a 0. It's not a 1 or 2 or 3. Classification is either a 1 or a 0, a 1, 2, or 3. It depends. You can have different classes. Then your data, you have to classify your data. You classify your data. That is classification. That, okay, this based on these features, does this fall into class A or does it fall into class B? So that's what you have in classification. But in regression, you don't have that. A good example of a problem that has to do with regression is you want to know the let me say the rates of the death rate in a country. You want to know the death rate in a country, or you want to know the extent or the degree that there will be rain. You want to know the degree that there will be rain in a particular location. Sorry for that. But in a classification problem, you are dealing with, would there be rain, yes or no? Is the death rate high or low? Okay, like you have on the screen, a classification classifier model or a model is the type of model in which the output variable, that is the label, is discrete. So it is, for example, we are predicting if a patient has a cancer or not. The person has the cancer or not. So the label is, the class is cancerous or it's not. Those are the classes. Then another example is if an employee will leave or stay. Like yesterday, I told you that if a product will be patronized or it will not be patronized. Okay, so these are some examples of classification problem. A good one which you will be very common with is, okay, in your mailbox you have a spam mail and a mail that is not spam. That is it. So it is the classifier or a classification algorithm that has been used to determine if a mail is spam or a mail is not spam. Okay, so we'll get to see more. We'll get to see more as we progress in this workshop. Please, if you are joining us, you can do well by sharing the link to others so that they can as well benefit from this training. And also, we do not claim to be master of all. If you want to contribute, you are very free to make your contribution via the comment section, or you contact us on Facebook, Instagram, or Twitter, and you make the comments. Our Twitter handle, which is uniform on all social media I've mentioned, is @HamplusHub. @HamplusHub. So we proceed to regression. A regression model is the type of model in which the output variable is continuous, like we said. Now you are predicting the price of house in an area. The price of house is not classified. It's not classified. Yes, so I might be thinking that here we have different kinds of apartments. We have a 2-bedroom flat, a 3-bedroom flat. Yes, we have them, but the price is not classified. That is to say, there's not a fixed price that a 2-bedroom apartment costs this amount. There's not a fixed price that a bungalow costs this amount. There's not a fixed price that a self-contained or a one-room apartment costs this amount. So it varies. It varies. That's prediction of house in an area. Okay. Another is how much rainfall will occur in an area. Okay, that was what I was telling you, that the extent of rainfall, that you are measuring the rainfall, you are not predicting if there will be rain or not. If you are predicting whether there will be rain or not, it is classification. It is classification problem. But if you are predicting the amount or the degree of rainfall, it is now a regression problem. Okay. If you have any comments, you are free to comment. Now, see, they have similarities. Both of them belong to machine learning algorithm called supervised learning, and both model a problem by learning a mapping function from the input x. In machine learning, we always use capital input X for the input to the output Y. That is in machine learning. That's, I guess this should be an error. The conventional way of showing our output is a little y, not a capital Y. A little y. So we have, though we have the differences, there are differences. We have the outputs. One is a regression algorithm, the other falls under classification. We have prediction. It predicts a continuous real output, a continuous real value, while the other predicts a discrete or value or a class. So you are predicting if a student will be a boy or a girl. You are predicting if the next election will be won by this party or the other party. That's just classification. Okay, now in a regression problem, we use a line of best fits. A line of best fit. If you can remember in your school days, you do plots, some kind of graph, and you find some above, some points above, some points below. Then you'll be asked to draw the line of best fit. And taking the line of best fit, you might find out that maybe a point is above the line or to just the line of best fit. That's what regression algorithm uses. And in this a classification algorithm, they make use of decision. What the lands, the experience, the data, it will use it to decide. Okay, talking about the evaluation of the metrics, what is used for evaluating, we can see we'll make use of mean square error. You can make use of mean square error. You can make use of mean absolute error. We can also make use of root mean square error. These are what we use to check the accuracy. That's how well our model performs when it comes to regression, how well the model is performing. But when it comes to classification, we don't use these metrics we use in regression. We use the metrics such as accuracy, F1 score, the area under the curve, that's AOC. You also make use of recall. We also make use of precision and precision. We make use of these metrics. Make use of these metrics. Okay. Now I'll not be concerned much with the mathematical representation, but I'll just try to explain it to you. Now in the mathematical, what you have there, you see y equals to the intercept, which is alpha plus beta x plus error. The error value, there will always be an error, a little error. There will always be an error. So from the regression model, there will always be an error. So the output is gotten by the intercept parameters and the slope, or what we call the beta. That is what gives us the output. Then from there we can measure our error. Now these are just steps involved in working on regression problem. The steps we take working on regression problem. Like we said yesterday, that once the cycle in machine learning, you must get your data. After you've gotten your data, first you must answer a question. There must be a problem for you to solve. After you've gotten the problem you want to solve, then you have to what? Get your data. After getting your data can be gotten from an existing data, or you can conduct your experiment yourself to get your data. After you've gotten your data, what next are you going to do? You have to clean the data. Of course, you load the data into the environment. After the data has been loaded, you clean it. That is loading the data, is taking the data which is either existing on a site, on a website, or you have it as an Excel file, or you have it as a database file, or you have it as a CSV, comma separated value file. You load it into your Jupyter notebook, or you load it into your Google Colab, then you work with it. But before working with it, you have to clean your data. I told you yesterday that cleaning your data, you have to remove the outliners. You have to remove the outliners. You have to remove the null values. You have to remove the values that have wrong data type. You have to ensure that all the duplicate values are removed. Why should I remove them? You should remove them because if your model is trained with unclean data sets, your model performance is going to be low. That is, to sum it up, your model performs as good as your data. Your model performs as good as your data. So, and in performing this cleaning process, we are most of the times data science skills are embedded into it. What I mean, you have to go through what we call EDA. You have to go through this elementary data analysis, and you go through it, and you have your visualization. Visualizations are very important because that is what you will use to explain to a non-techie. Use visualization to explain to a non-techie. But if you are with a techie, you can use your codes to explain to the techie. Okay, so we proceed from our cleaning data to what we call your segmentation. You segment your data set, which means the data set you've gotten, you should use a 70-30% for training and testing. That's, you split your data set into two, one to train, the other to test. And I did mention yesterday that some experts, some professionals in the field of machine learning actually perform their data segmentation in this way. The 60% for training, 20% for validation, and 20% for testing. And remember, I told us yesterday that we should ensure that after the model has been validated, or after the model has before we use the testing data on the model, we should ensure that the model has been trained finally. It is not a good practice that after you've tested your testing data on your model, then you now begin to perform your parameter hypertuning. No, hyper parameter tuning. No, and you begin to change your values to see how well your model will perform better. No, it won't give you good accuracy. So before you use your test data on your model, you should ensure that you perform your model accuracy, your model hyperparameter tuning. You perform your hyperparameter tuning, and that is why it is important for you to use that 20% for validation, so that when you use your validation data on your model and it performs not to the degree you want it, you can hypertune your model and use the validation data again before you use it on your test data. Okay, so briefly we'll be going straight to the practical section for today. Like I said earlier, if you are just joining or you know someone that will be interested in this training, this workshop that is free, of course you can do well by sharing the link to the individual. You share the link to the person and let the person join. Okay, thank you. So on your screen you can see very well that we have our Jupyter notebook already open. Remember yesterday I showed us how you can open your Jupyter notebook, and I did also explain how you can download your Jupyter notebook. Please, if you want to see this know more on how to open your Jupyter notebook, how to create a notebook, please visit yesterday's video. Okay, so the first thing you have to do in your Jupyter notebook, you have to import the libraries that you're working with. Now, I will take a little time to explain the libraries you see there. The first library you see there is NumPy. NumPy is a Python library which is used for numerical computing. Used for numerical computing. Using Python, you can perform your matrices. Using NumPy, you can perform your matrices, you can perform statistics, and you can perform some other things. So that is a very essential framework or a package in the engineering field. Okay. The second you have there is Pandas. Pandas is built on NumPy. But the difference between Pandas and NumPy is Pandas' ability to perform beyond numeric computing. What am I saying in essence? Pandas uses both numerals and string in its computing, while NumPy uses only numerals. That's why with Pandas we can create a data frame. With Pandas we can perform some calculation, some computing, actually let me not call it calculation, some computing on string variables, and the concept of creating a data frame in Pandas, using Pandas, is using the concept of a dictionary. I will show you how to create a data frame from a dictionary, and I will also show you how to create a data frame from a list. So I press my Control Enter or Shift Enter or for the first cell to be executed. While it's executing, I will also tell you about the third package you have there, Matplotlib. Matplotlib is a package for visualization. Is the package used in Python for visualization. There are other packages you can use for visualization in Python, something like as Seaborn. You can use Seaborn for visualization. You can also use Plotly Express. You can also use Plotly Express for visualization. There are other packages which you can use for visualization, but you can use the package or the framework, you are free, you understand better, and that is easier to be used. Seaborn is built on Matplotlib. Seaborn is built on Matplotlib. Okay, so this is our data set, but prior to importing our data set, let me show you how to create a data frame. A data frame from a list. Okay, so we have this list. Okay, let me call it students. Okay, sorry, because so this we have one is Anita, the other is Paul, the other is Joy. Let me just use 3. And we have, okay, students underscore students. Okay, this is the right way, sorry. Students is the name is Anita, and she's 30 years old. She lives in London. She lives in London. That is student 1. Student 1. Then we have student 2. Student 2. His name is Paul. Is 29 years old. He lives in Nigeria. This tutorial is from Nigeria. We have student 3. And most of our sponsors are from Nigeria. Student 3, Paula, she's 33 years old, and she lives in Turkey. That is Turkey. So we have these 3 lists as presented. Then to create the data frame, say df, or can call it let me call it df underscore students is equal to, this is pd. We are importing pandas. Pandas has been imported as pd, so we are not going to use pandas in full. We are going to use the array as pd. That is the conventional way of importing pandas. Is a pd dot the data frame. Please take note that the data frame is a capital D and a capital F. So what are we going to do? We are going to supply the data, which is, we are using a double bracket because it's more than one list. So we have students. We have student 1, student 2, and we have student 3. Okay, then I'll have columns. That is the name, the column names. So I'll have I have name. Okay, the next one is age, and the next is location, or let me say country. Okay, with this I can have my df execute this cell. Let's see what the outcome. Oh, df is not defined, sorry. That is df underscore student underscore student, and voila, this is what we have as a simple data frame. You see, and from this data frame, before we proceed to today, let's just do some kind of thing. I can sum the ages. I can do a simple calculation as a sum. What is df? df underscore stud age. Good. If I say do this, it gives me an error. Why? Because age ought to be in string. Of course, it's a string. So it gives me this, and you can see vividly from the screen that is okay. Okay, I can sort this data frame. First, before I sort the data frame, I can sort it by using age. I would like to sort the data frame using age. Before that, I'll tell you I'll be able to present to have some mini data frame, which is df underscore stud. I have this, and I say, okay, give me the age and give me only the location out of the data frame. Then I have this, okay, key error location. Okay, location is country, please. I don't know why I'm making use of location. So I'll have this. I'll have the name, the age and the country. That's all. So for me to sort the data frame, I have to do df underscore stud good dot sort values. I have to sort the values since I'm sorting the values. What am I sorting by? I'll have by, I'm sorting by age. So I'm sorting by age, and that is all. So how do I want it? I want it ascending equal to true. Okay, so once this is sorted, I'll have it. I've sorted it. You see, even the index number shows you that it has been sorted. Now, after sorting, how can I change the index number? Okay, I can perform another code by using drop dots reset index, and I say good, go, and it has changed it. You see the new index here, but I have a problem. The old index was appended to the data frame, and I don't want this to happen. So how can I do it? So in the reset index, I'll have to supply this drop equals to true, which means drop this index after resetting it. So I'll have this. You see, this is the perfect example. Please, if you have any question, you can let us know through the comment section. And apart from having any question, you can also feel free to contribute. We do not claim to be masters of all. Okay, so let's go back to what we have today. Because of time, we are short of time. Now, the data set we have is an Excel data. Data is in Excel format. Want to load it into this environment. So we just have to load it. I'll use through the location. I'll use pd.read_csv because it is in CSV. If it were to be in Excel, I'll use read_Excel, because if I go to pd.read, I'll have so many pd.read. It will show me that I can read a lot of things. I can read from the clipboard what I've copied. I can read a CSV file. I can read an Excel file. I can read an HTML file, even a JSON file. There are a lot of files that I can read. I can read from SQL table, SQL query, and that is all. So I can do a lot of read through my Pandas. Okay, so this has taken in the data. Let us observe the data frame. Okay, we have this is from a this data is from a restaurant, and we have the bill. Okay, now and the detail of people that goes there. We have the gender, we have their characteristics, if they are smokers or not. We have the day, they went to the restaurant, and what the time, if it's lunch, dinner, and we have the size. The size is just an indication of how many people went there. That is the size. Okay, we have that tip. That tip actually is after the total bill. Did the customer give the attendant an extra money? That is the tip. Okay, your bill is 2,125 naira. Okay, anyway, take it. So you have a change of 360 naira. Oh, don't worry, you can keep the change for yourself. That is the tip. Okay, now the problem we are going to solve is, what is the probability that is a customer will give a tip in the restaurant? So remember, I told you we can see this. We want to view the first 56 rows, and what we want to view in this first 56 rows is just the total bill and the tip. Okay, that is what that code is all about in line 13. Though it is first 56, I shorten it using the dot head. The dot head will enable you to only see by default the first 5. But if you include any number in the parentheses, it will show you those numbers. The opposite of dot head is dot tail. So dot tail gives you the last 5 observations, or the last 5 rows in your data sets or data frame. Okay, dot info gives us the information. From here we can begin to perform some basic EDA, and we'll be able to see that, okay, total bill has 744 non-null. First, let's look at our total entry. Our total entry is 744 entries. That is the range index. So we find out that column 1, which is total bill, have no null value, and that's all. The data has been claimed. There are no null values. Then it gives you the D type or the data type. It tells you if there are floats, that it had the decimal point, or if there are objects. Object simply means that it is a string. Pandas interprets a string as an object, or it tells you if it is what? If it is an integer. There's another data type, which there are other data types in Pandas, such as the date time and the category. Okay, why this dot shape tells us the shape of the data, which is simply the number of observations by the number of rows. By the number of columns. So we have 7 columns, number from 0 to 6, and we have 744 observations, number from 0 to 743. Okay, this size tells us the size of the data frame, which is simply the number of observations multiplied by the features. Sorry, if I use observation, I mean row. If I use feature, I mean column. These are machine learning terms. Okay, we want to see data.describe. Data.describe will give you both like the sum, the average, the mean, the percentile, and whatever. That's what data.describe will give you, and this gives you for the numeric values. For the numeric values, to get for the categorical, I will just show you how you can get for the categorical variables. Okay, that is those variables that are not numeric. I'll have to use here include, which is include objects. Include objects. So once I include objects, I will see a different description. I'll see a different description. So when I include it, because you should know that a string cannot tell me the mean. I can't have the mean of the string. I can't have standard deviation of the string. So it just gives me the counts, the number of unique values, the top, and the frequency. That is just it. That's what the other describe does. Okay, now I am beginning to perform my EDA. So I'm going to use a box plot, and in using a box plot, I want to perform I want to see the visualization of gender against T. I want to see the visualization of gender against T, and the data is what is the data I'm using, which is the data frame, is data. That is the variable, the data variable. So I said you should label the Y column as amount of T. So from here we can visualize that the male and the female, okay, they gave almost the same number of tips, male and female. They gave tips, but there's something else you can see in the male and female section. There's something else you can see. Now you see above this box plot, let me try to explain this box plot. You see this box here shows us the mean, or what you call the 50th percentile. Tells us the 50th percentile. When you look here, when you look at this place, you find out that the tip will always have 50th percentile at 320. And look at it here, look at this value. If you can trace it down, it's within that range. It's within that range. So the mean is within. So it's also telling us about what we have seen in the describe. What we have seen in the describe. You see the standard deviation of the tip is 148. You go down, you see standard deviation. Standard deviation. Okay, now let me show you something else that you might have not taken note of for those that are new, but the experts in machine learning, they will observe this. You see this male, you see this dotted line above this line, you see this line here, is what we call outliners. And these outliners, if they are not taken, it will affect the model. It will affect the model. But for today, we'll build this model with these outliners. Then tomorrow, I'll show you how you can take away the outliners, and you will build the model, and you see a better performance. So for you to hide this little text displaying here, just use your semicolon and you run this, you see the little text is gone. Okay, and this one will see the tip against the day the tip was given. It will also display this for us. You can use your semicolon to do this, and it closes. And you see the days, the different days and their tip. You find out that only Thursday, Monday, Wednesday that does not have outliner. The other days have outliners too. Okay, now what to start our model building. Remember yesterday I told you we are going to use sklearn. We'll be using sklearn, which is a scikit-learn, and in scikit-learn we have a lot of algorithms, but first we'll be making use of the train test splits, because we want to split our data sets. You can split your data sets manually, Yeah, you can also split your data sets using the train test splits function or module of the scikit-learn. So this is what we have to do for splitting the data first before we perform our vertical split, horizontal splitting. Before we perform our horizontal splitting, we must split vertically, which is we have to take away the x from the y. You should understand what I mean. You have to take away your inputs from your outputs, because both of them are always in the data sets. Okay, now what is our input? Our input is everything we have here excluding this tick. What you want to predict is your output. We should get it clear. What you want to predict is your output, or let's say what you are predicting is your outputs, and the others constitute your input. Okay, so that is what we did here. We use .drop. If you say data.drop tip, and the all others you give it to x. Now using .drop, it will drop tip here, and it tells me this axis equals to 1 is very important, because it tells me go to the columns and find where tip is. If axis is equal to 0, it means goes to where? Go to the index, that is to the rows. Okay, but tip is in column, so it is 1. Then we present this, we find out that you have the data set excluding the tip, because the tips has been dropped, and that constitutes our x. Now our y is just the tip in the data set. This is our y. Okay, we've gotten this. Now there's something we have to do. Now this pd.getDummyX, what will it do? This will because our model cannot be trained. Remember yesterday I said it, our model cannot be trained with non-numeric values, especially regression. It cannot. So we have to turn them to categorical, turn all the categorical variables to numeric variables. So let's see this. We've done that, and let's see. Before we see the shape of our x, let's view it, our x new. So let's view x underscore new, and you see what you have there. Good. So you find out that the gender, because the gender consists of two categories, male and female. So it assigned all the male one, and it gave 0 to the female. The smoker consists of two categories, yes and no. So it changed it to 1 and 0. That is just how it changes it, so that it can fit well into our model and perform its its prediction and training and prediction. So this is for our shape. Now we see the shape has increased. When you turn your categorical variables to numeric variables or to discrete variables, you find out this is also called one-hot encoding. After you've done this, you find out that the shape will increase with respect to the columns, not with respect to the rows. So our rows are still very much intact, but the columns has increased. Okay, now we've done the vertical splitting, like the x and y. The next we have to do is the horizontal splitting. That's okay. Take this percent as what is called take this percent for test, take this percent for train. Good. Here we are splitting just test and train. We're splitting test and train. Tomorrow I will show you how you can split test and train and validation. test, validate, and train, validation, and test. I'll show you how you can do that tomorrow. So here, just simply, I just call the module because remember I've imported it from scikit-learn, which is sklearn.model selection input train test split. So I just came down here. And I called the model, the function train test split. Good. So what this will return, it will return to me a tuple. I know the concept of packing and unpacking in Python. That's why we have x train, x test, y train, y test. This is what it will give us. Okay, let's do this first and foremost. Let's see when we not assign that. Let's see the output so that you will understand it better. Train test split is not defined. Let me get that. Why did I not run that cell? Oh, I didn't run the cell. Oh, so sorry. So I just run the cell now, and I came down here to run it. Now you see this. This is our X string. This first list like this is our X string. This is our X test. Then you see this. This is what our see our X test. Then this, thank you. This is what our Y train, and this is our Y test. Okay, now let me perform it and equate it to it. See, it gives you the length. It gives you the length. When you see this plus this, remember I told it to use what from this code up here. I said, okay, this is what you are splitting. You are splitting X and Y. After splitting X, you split Y. The test size is 0.2, which is splits give me 2%. That give me 20% of the data for tests. Then 80%, the remaining 80% will be for train. So that's why you see here that the train data is 595, while the test data is what? Is 149 rows. Good. So you know it is a random state, so I just include this number. So whenever I run the code again, I will have similar thing. Now if I should remove this random state, and run this, look at here, I have 1656. I run it again, it gives me another random number. So for me to always have the value that was used to train the model, I must include what? That random state. So that whenever I run the code again, I will not have any change that will affect the model. I can put any number there. One of my mentors, which is one of my mentors in World Quant University, he always uses 42. But in this scale, I just use 1, 2, 3, 4. It's just any number. It doesn't matter. Good. Okay. So let's proceed. After this has been done, then what do we have to do? We have to import the model. And remember, it's a regression model, and we get it from scikit-learn or linear model. Also, in this scikit-learn or linear model, you get your logistic regression model. Okay, we have this. We train our model. In this model we are training, we would not specify any parameters, but there are a lot of parameters that you can specify from your model when you come to parameter hypertuning. When you have a linear regression, to see those things, you do this and it tells you more about it. You see the parameters, you can have the fit intercept. By default, it is true. The normalize, by default, it is false. The copy X, by default, it is true. The end jobs, by default, it is none. That is the number of times you want it to proceed. The number of time you want it to proceed to perform that iteration, and the positive, you have it there as false. Okay, so most times in the parameter hypertuning or hyperparameter tuning, it is the end jobs that we work on. Okay, so we'll proceed after training, after initializing our model. We just initialize the model in line 37. We have to train the model, and we are using what? The X train and the Y train. Remember, it's a supervised learning. If it were to be unsupervised learning, we are going to use only X train. But because it is supervised, we are using X train and Y train, which is the input and the output to train. But in unsupervised, we only use the input to train. After training the data, we see that this has been trained. Then we want to predict. We want to see model.predict X train. That is that X test. What we have there as X test, the model should predict it. The model should predict the values, the output for X test. You give us the 20 values for X test. Now you see this. This is the model prediction. This is model prediction for using X test. Is now predicting the output. Now remember, we split the model, and we have our Y test. Y test has not come into the model. Y test has not come into the model. Y test is just from the data frame or the data set. Now let's compare and contrast. Now you see from our Y test, you see the values are similar with what we have with this. Now at this point, it is very wrong for me to go back and do my parameter hypertuning in line 37. It is very wrong. So because I have used I've used my test data on my model, so I just have to proceed. Remember, I told you we are just doing this today for you to understand. Tomorrow we should have a better model. We will take away the outliners. We will ensure that we do a better parameter hypertuning to come very close to the prediction. Now you see our Y test recorded 392 naira was the tip given, but our predicted our prediction is that for that particular value, it is 367 naira that was given. You see the difference? Okay, so let's see. We stored that in predicted. We want to see the difference in the prediction, and now find out that there are difference. At times the model will predict high, at times it predicts low because of all those outliners and lack of parameter hypertuning. So this is using mean square error to see the performance of the model. How well is the model performing? And you see our model is look at the mean square error of our model. Now for you to get let me perform this. For you to have your baseline to know how well your model does is data tips dot sort value the sort values normalize equal to true. A moment. Okay, sorry. Oh, sorry, can't values. Values can't, sorry. Values can't. Values can't. Count values, normalize. That's true. Let me see. Data.t. The above keywords direct us on tips. Let me see. Tips. Don't we have tips? Okay, it's tip, not tips, please. Tips, not tips. So tip, not tips. Okay, let me see this. So object has no object values count. Okay. Okay, I wanted to get marks of data T tips by the count of data, count of data. Okay. Sorry, the length, sorry, the length. Data tip. I don't know why I'm using tips. I don't know why I'm using tips. Okay. So, where we find the square root of the mean square error, we have this 142. So you see that most times our model performs lower, at times it performs higher. It predicts higher, sorry, it predicts higher, and at times it predicts lower. So the model is not doing too well. The model is not doing too well. If we get, sorry, not here, not marked, but some, if we get our model performing better, good, we'll have more accurate result. So tomorrow we'll see our model, how to make our model to perform better. Tomorrow I will show you how to calculate the baseline and some other things. So please, if you have any questions, you can please drop your questions on the chat or the comment section, or on the chat section if you can see it. If you can't see it, you can contact us on all our social media using Facebook, on Instagram, on Twitter, using @Matplotlib. Just use @Matplotlib. Then you will connect with us. We are also on LinkedIn. You can connect to us, you can ask your question, you can make your contributions, and we'll be very glad to see all your comments and contributions. Thank you to all the viewers, and thanks to Mr. T, who commented on yesterday's section. If you missed yesterday's section, you can do well by visiting the YouTube page, which you are on now, and see the section for yesterday. Okay, I just dropped the link For those that missed yesterday's section, you can watch it and get updated. Tomorrow, we'll be improving on this model we built today, and also we will look at another model. We look at another model, maybe decision tree or maybe logistic regression. We'll proceed to better our knowledge in machine learning. Thank you very much. Once again, this is from Hamplus Technologies International, also known as Hamplus Hub. And the resources we'll use are from most of our sponsors, our mentors, those for resources from Global AI Hub, resources from Data Scientists Network, formerly known as Data Science Nigeria, located in Nigeria, and Global AI Hub is located in Turkey. Thank you very much for joining us. Tomorrow, same time, 12 a.m. 12 noon, same time, 12 noon, will be on this channel. Thank you. Do have a nice day.